This tutorial shows you how to calculate the minimum required sample size for the repeated measures ANOVA with G-power. When we start G-power, we get this overview by default. We now need to select the repeated measures ANOVA first. Select it via Tests, Means, Repeated Measures, Within Factors, ANOVA approach. Now you have to select the type of power analysis. Since you have to calculate the minimum required sample size in advance, you have to select a priori. The first input parameter needed is the effect size f. If you have a comparable or preliminary study, use the reported effect size from there. The reported effect size is usually Eta². You can calculate f from Eta² and vice versa. Use the following formulas taken from Cohen 88, page 281 and 284 respectively. If no comparable studies exist, fall back to research field specific thresholds. If those are also non-existent, the conventions for the behavioral sciences 0.1, 0.25 and 0.4 for small, medium and large effect sizes taken from Cohen 92 can be used. The second input parameter is the alpha error probability, which is the probability of committing a type 1 error. In short, this is the probability of wrongly rejecting the null hypothesis. 5% is the typical convention, 1% is a bit more restrictive. A value above 5% should be avoided though. The third input parameter is power. Power equals 1 minus the beta error probability. Beta error is the type 2 error. In short, this means falsely retaining the null hypothesis. 95% power is typical, meaning you have up to 5% type 2 error probability. In some research fields, 0.8 is used here. This means you automatically accept a type 2 error of up to 20%. If you have power lower than 0.95, this usually calls for a reasonable justification. The fourth input parameter is the number of groups. This should be pretty obvious. A repeated measures one-way ANOVA has only one group. The fifth input parameter is the number of measurements. This is the number of points in time measurements exist for. For instance, you have a baseline measurement and 2 follow-up measurements, meaning you have a total of 3 measurements. The correlation among repeated measurements can be left at 0.5 and only changed if you have specific numbers from previous or preliminary studies. The Nonsphericity correction should only be changed if the variances of the differences between the measurements are unequal. It will be difficult to determine this in advance and therefore leave it at the default value of 1. Finally, hit calculate to see the minimum number of observations needed for the repeated measures ANOVA to detect the presumed statistical effect with the predefined type 1 error probability and power. As a rule of thumb, a smaller effect size and a larger power require more observations than the other way around.